video, we are going to solve problems in binary operations. I already have a 1-hour video on the introduction to binary operations. So I will put the link to that video in the comment section. So you can watch that video if you don't understand anything in this question and answer session. So let's start with this problem. The operation delta is defined on the set of real numbers R is P operation Q equals PQ over 4 plus P plus Q, where PQ is a member of real numbers. Find the inverse of Q. Now, the rule says that the inverse of Q inverse, operation Q itself should be equal to the identity element E. So if you look at this equation, you see that the missing thing is the identity element. So we don't know the identity element. So the first thing is to be able to find the identity element. Now, the rule also says that Q operation, the identity element, is equal to Q itself. So let's first start with Q operation, the identity element. But remember that the operation is defined as P operation Q equals PQ over 4, then plus P plus Q. So what this means is that Q operation, the identity element, wherever we see P, we need to replace it with Q. And wherever we see Q, we need to replace it with E. So in this case, here is PQ. So here will become QE over 4. Then plus P is Q. And then plus Q, and Q is E. So plus E. However, we said that Q operation E is equal to Q. So what this means is that QE over 4 plus Q plus E should be equal to Q. So let's multiply through by 4. By the way, this Q and this Q will cancel out. So what we can do is that we can multiply through by 4. So QE plus 4E is equal to 0. So now, let's factorize E. So if you factorize E out, we are left with Q plus 4 equals 0. So we know from here that E is equal to 0. Now, having gotten the identity element, then we can do this operation. We said that Q inverse operation Q is equal to the identity element E. So Q inverse, but we know that P operation Q is PQ over 4 plus P plus Q. So P operation Q is equal to PQ over 4 plus P plus Q. So now, Q inverse will be P, and then this Q will be Q. So if we do it, you see that here will be Q inverse times Q over 4 plus Q inverse plus Q is equal to E, but E is equal to 0. So this is equal to 0. So we are looking for Q inverse. So let's bring Q to the other side. However, let's multiply by 4. So you see that Q inverse times Q plus 4Q inverse plus 4Q is equal to 0. So let's take this 4Q to the right hand side. So we have Q inverse times Q plus 4 times Q inverse is equal to minus 4Q. So if we factorize Q inverse out, we are going to be left with Q plus 4 equals minus 4Q. So Q inverse is equal to minus 4Q divided by Q plus 4. However, Q cannot be equal to minus 4, because if Q is equal to minus 4, Q inverse becomes undefined. A binary operation delta is defined on the set of real numbers R, by x operation y equals x plus y plus 10. Find A, the identity element, and then B, the inverse of 3 and minus 5 under the operation delta. So now, the operation is x operation y equals x plus y plus 10. Now, the identity element is x operation, the identity element is equal to x itself. So let's do x operation, the identity element. So it means that wherever we see x, we replace it with x, and wherever we see y, we replace it with the identity element e. So this becomes x plus e plus 10 equals x. So you see that this x and this x will cancel out. So e plus 10 is equal to 0. So e is equal to minus 10. What this means is that the identity element is minus 10. So having gotten the identity element, we can find the inverse of x, which is x inverse. But we know that x operation x inverse is equal to the identity element. So what is x operation x inverse? Wherever we see x, we replace it with x, and wherever we see y, we replace it with x inverse. So this becomes x plus x inverse plus 10 equals the identity element, which is minus 10. So let's make x inverse the subject. So x inverse is equal to minus 10, then minus 10, then minus x. So x inverse is equal to minus 20 minus x. So we can factorize minus 1 and then say x inverse is equal to minus into brackets 20 plus x. Now the question is saying we should find the inverse of 3 and minus 5. So let's first find the inverse of 3. What it means is that wherever we see x, we replace it with 3. So x inverse of 3 is equal to minus into bracket 20 plus 3. And that is equal to minus 23. So the inverse of 3 is minus 23. Now let's find the inverse. Okay, let me do it here. The inverse of minus 5. So wherever we see x, we replace it in minus 5. So x inverse of minus 5 is equal to minus into bracket 20 minus 5. And that is equal to minus 20 minus 5 is 15. So the inverse of minus 5 is minus 15. A binary operation asterisk is defined on the set of Q of rational numbers as A over B operation C over D equals A plus C over BD. Evaluate 2 over 3 operation 3 over 5. So you can see that the operation is this. Now 2 over 3 operation 3 over 5. So you can see from here, if we compare, here's A over B. It means that A is equal to 2 and then B is equal to 3. Then here C is equal to 3 and then D is equal to 5. So 2 over 3 operation 3 over 5 is equal to, it says A plus C, so which is 2 plus 3 divided by B times D. B is 3 times D 5. Sorry, yes 5, not 15. So 2 plus 3 is 5 divided by 3 times 5. So you see that this 5 and this 5 can cancel out. So at the end of the day, the answer is 1 over 3. A binary operation delta is defined on the set of real numbers R by P operation Q equals P squared minus 2PQ. Determine whether or not delta is commutative. And then B, find the true set of P operation 4 equals Q. So now, the operation is P operation Q equals P squared minus 2PQ. So to determine whether it's commutative or not, P operation Q must be equal to Q operation P. So we have P operation Q. Let's find Q operation P. That will be equal to wherever we see P, we replace it with Q. And wherever we see Q, we replace it with P. So here becomes Q squared minus 2QP. So if we rearrange, here becomes Q squared minus 2PQ. So you see that the first part, P operation Q, is P squared minus 2PQ. But Q operation P is Q squared minus 2PQ. So you can see that P operation Q is not equal to Q operation P, and therefore the operation delta is not commutative. So let me put therefore here. Therefore, this operation is not commutative. Then the second part of the question says we should find the truth set of P operation 4 equals Q. Now, we know that the operation is P operation Q equals P squared minus 2PQ. So what it means is that wherever we see P, we replace it with P. Wherever we see Q, we replace it with 4. So this becomes P squared minus 2P times 4 equals Q, and Q is 4, so it's equal to 4. Sorry, I wrote the wrong question. Here's 9, not Q. Please pardon me. Here's 9. So P operation Q equals 9. And therefore, here is supposed to be 9. So P squared minus 8, 2 times 4 is 8, so minus 8P is equal to 9. So P squared minus 8P minus 9 is equal to 0. So two numbers that when we multiply, we'll get minus 9. But when we add, we'll get minus 8. So you see that minus 9 times 1 is minus 9. However, minus 9 plus 1 is minus 8. So the factors are P minus 9 in one bracket, and then P plus 1 equals 0. So the values of P are P equals minus 1 or P equals 9. A binary operation delta is defined on a set of real numbers R by P operation Q equals 2 times into bracket P minus Q minus into bracket 1 over P plus 1 over Q, where PQ is a member of real numbers. Evaluate 1 over 2 operation into bracket minus 1 over 4. So P operation Q equals 2 times P minus Q minus 1 over P plus, so here's 1 over P plus 1 over Q. So 1 over 2 operation minus 1 over 4. It means that wherever we see P, put 1 over 2. Wherever we see Q, put minus 1 over 4. So this becomes 2 times 1 over 2 minus 1 over 4. And then minus into bracket 1 over 2. Then plus 1 over minus 1 over 4. So this is equal to 2 times 1 over 2. Minus becomes plus 1 over 4. Then minus. Now 1 over 2 is 2. Then minus 1 over 4 becomes 4. So let's find the LCM here. It is 4. 4 divided by 2 is 2. 2 times 1 is 2 plus 4 divided by 4 is 1. 1 times 1 is 1. Then minus 2 minus 4 is minus 2. So 2 plus 1 is 3. So here is 3 over 4. And then plus 2. Sorry, I made a mistake. I ignored the 2 here. So here is times 2. So you see that 2 will cancel here 2 times. So therefore, here will be 3 over 2 then plus 2, which is equal to 7/2. A binary operation, delta, is defined on a set of real numbers by P operation Q equals P plus Q minus 2PQ, where PQ is a member of real numbers. A. Show that delta is commutative. B. Find the identity element under the operation. And then C. Which element in R has got no inverse under the operation? So it is P operation Q is equal to P plus Q, then minus 2PQ. So to be able to show that it is commutative, P operation Q must be equal to Q operation P. So let's find Q operation P. This will be equal to, wherever we see P, replace Q. Wherever you see Q, replace P. So here becomes Q plus P minus 2QP. So if we rearrange, it becomes P plus Q minus 2PQ. So you can see that P operation Q is equal to Q operation P, and therefore delta is commutative. The second part says we should find the identity element. Now for the identity element, P operation, the identity element must be equal to P. So let's find P operation, the identity element. That is P plus E minus 2PE should be equal to P. So you see that this P and then this P can cancel out. So if we factorize E out, we are left with 1 minus 2P equals 0. So you see that outright, the identity element is equal to 0. So having found the identity element, the question says which element in R has no inverse under the operation. So we need to find P inverse. But we know that P operation P inverse must be equal to the identity element. So let's do that. So P operation P inverse becomes, wherever we see P, replace it with P. Wherever we see Q, replace it with P inverse. So this becomes P plus P inverse, then minus 2P times P inverse equals the identity element, which is 0. So let's take this P to this side of the equation. So it becomes P inverse minus 2P P inverse equals minus P. So let's factorize P inverse out. We are left with 1 minus 2P equals minus P. So therefore P inverse is equal to minus P over 1 minus 2P. So for this to have no inverse, it means that this denominator must be equal to 0. So 1 minus 2P must be equal to 0. This implies that 2P is equal to 1, and therefore P is equal to 1 over 2. So the only element that does not have an inverse is 1 over 2. A binary operation asterisk is defined on a set of real numbers by A operation B equals A plus 2 divided by A plus B. A equals minus B. I. Evaluate 3 operation root 2, leaving your answer in the form P plus R root 2, where P and R are rational numbers. And then II. Find X such that 2 operation X equals 3 over 2. So the operation is A operation B equals A plus 2 divided by A plus B. So we are supposed to find 3 operation 2. So 3 operation root 2 equals, wherever we see A, put 3. Wherever you see B, put root 2. So this becomes 3 plus root 2. 3 plus 2. So this becomes A plus 2, which is 3 plus 2 divided by A plus B, which is 3 plus root 2. So to further simplify this, this becomes 5 divided by 3 plus root 2. So let's continue from here. So it is 5 divided by 3 plus root 2. So we can simplify this by rationalizing. Multiply both numerator and denominator by 3 minus root 2 divided by 3 minus root 2. So it becomes 5 times 3 minus root 2. Then you can see that here is difference of 2 squares. So it becomes 3 squared minus root 2 squared. So 5 times 3 is 15. Then 5 times minus root 2 is minus 5 root 2. Divided by 3 squared is 9 minus root 2 squared is 2. So this is equal to, let's continue from here. This is equal to 15 minus 5 root 2 divided by 9 minus 2 is 7. So this is equal to 15 over 7 minus 5 over 7 root 2. Then the last part of the question says that we should find x such that 2 operation x is equal to 3 over 2. So let's find 2 operation x. This is equal to 2 plus 2 divided by 2 plus x. And then he says this should be equal to 3 over 2. So 2 plus 2 is 4 divided by 2 plus x equals 3 over 2. So what we can do is that we can cross multiply. So this means that, let me continue from here. 3 times 2 plus x is equal to 4 times 2, which is 8. So 3 times 2 is 6 plus 3 times x, 3x equals 8. So 3x is equal to 8 minus 6, which is 2. And therefore x is equal to 2 over 3. The binary operation, this is defined on m operation n equals 1 over 2 into bracket m minus n. A, form a table of operation on the set t equals 2, 4, 6. And then B, state whether or not the operation is closed under t. And then II, it is commutative under t. So let's first draw our table. So the values we are given is 2, 4, 6. But this is the operation. So we need to fill here with 2, 4, 6. And then here also be 2, 4, 6. Now, m operation n is equal to half of m minus n. So here is 2 operation 2. So 2 operation 2 is equal to half of 2 minus 2. 2 minus 2 is 0. 0 divided by 2 is 0. So this is equal to 0. And therefore here ought to be 0. Now let's find 2 operation 4. That is equal to half of 2 minus 4. Now 2 minus 4 is minus 2. So it becomes minus 2 over 2, which is equal to minus 1. So here is minus 1. Now let's find 2 operation 6. That is equal to half of 2 minus 6. 2 minus 6 is minus 4. So here we can minus 4 over 2. And that is equal to minus 2. So here is minus 2. Now let's find 4 operation 2. That is equal to half of 4 minus 2. And that is 4 minus 2 is 2. So 2 divided by 2. This is equal to 1. So here is 1. Then let's find 4 operation 4. That is equal to half of 4 minus 4. 4 minus 4 is 0. So 0 divided by 2, which is equal to 0. So here is 0. Let's find 4 operation 6. That's equal to half of 4 minus 6. 4 minus 6 is minus 2 divided by 2, which is equal to minus 1. So here is minus 1. Then we can also find 6 operation 2. That's equal to half of 6 minus 2. 6 minus 2 is 4 divided by 2, which is equal to 2. So here is 2. So let's find 6 operation 4, which is equal to half of 6 minus 4. 6 minus 4 is 2 divided by 2, and that's 1. So here is 1. Then finally, let's find 6 operation 6. That is half of 6 minus 6. 6 minus 6 is 0 divided by 2, which is equal to 0. So here is 0. Now let's come to the questions. He says that state whether or not the operation is closed under T. Now you can see that this is the numbers of T. So an operation is only closed if all the elements that we found after the operation can be found in what? T. But you see that T is what? 2, 4, 6. But now we found 0 here. There is minus 1 here. There is minus 2. There is 1. All these elements are not found in T, and therefore T is not closed. T is not closed. Now, he also says we should find whether the operation is commutative. Now, let's come and find for operation 2. What is for operation 2? For operation 2 is what? 1. Now, let's find 2 operation 4. So 2 operation 4 is what? Minus 1. But 1 is not equal to minus 1. It means that the operation is not also what? Commutative, because 4 operation 2 is not equal to 2 operation 4. We only need one example among the lot to prove that it is not commutative.